Let's talk about scope rules next. Consider a situation where, in different places of your code, you have defined several functions called update or several variables called x. How do we know which update function or which x variable Python uses at any given time? We know from before that each variable name belongs to a certain abstract environment or namespace, and we can think of it as a context in which a given name exists. This is analogous to many everyday situations that require context for names to be meaningful. So when you talk about your friend John, your other friends know intuitively which John you're talking about. But how does Python know which update function to call or which variable x to use? The answer is that it uses so-called scope rules to make this determination. It searches for the object layer by layer, moving from inner layers towards outer layers, and it uses the first update function or the first x variable that it finds. You can memorize the scope rule by the acronym LEGB. It may not be the catchiest acronym, but it works. Here's what the different letters stand for. L stands for local, E stands for enclosing function, G stands for global, and B stands for built-in. In other words, local is the current function you're in. Enclosing function is the function that called the current function, if any. Global refers to the module in which the function was defined, and built-in refers to Python's built-in namespace. If Python cannot resolve the name, meaning if it cannot find an object having the name you've requested, it raises a so-called name error exception, and the execution of your program typically stops at this point. Let's practice scope rules first by defining a function called update that has no parameters. Def update parentheses and colon, then we have x dot append 1. All this function does is that it appends, or at least tries to append, the number 1 to an object called x. When we run this function update, Python gives us a name error and tells us that a name x is not defined. Let's see what happens if we define a list called x and then call the function. X is a list consisting of two elements, 1 and 1, and then we call the function update. You might be surprised to see that the code now runs and appears to modify the list x. To understand what is happening, let's go through the steps that Python goes through when it tries to find object x. Using the LEGB rule, it first looks for x in the local scope inside the function update, but x does not exist within this scope. It then moves on to the next layer, which is enclosing functions, but in this case there are no enclosing functions because we didn't call the update function from inside another function. So let's move on to the next layer, which is the global layer, the module or namespace where the function update was defined. The global layer or scope does contain an object called x. It is the x that we defined right here. And since this is the first object of that name that Python found, this is the object that it will use. This example, focusing on scope rules, shows that you can manipulate global variables, variables defined in the global scope, from within functions. Functions that modify either their inputs or objects defined in other parts of the program in this type of behind-the-scenes manner are said to have side effects. For example, if you look at the function call, which in this case is simply update followed by parentheses, it is not clear that the function has side effects. This is a programming style that you should generally avoid because it can lead to programming errors that are very difficult to find. Let's then consider a slightly more complex example about scope rules. This example demonstrates both scope rules and mutability and immutability of Python objects. To get going, let's first write two short functions. Our first function is called update, and our second function is called main. In this case, the main function calls the update function as part of the program. We would like to know what are the values of n and x at different points of the program's execution. Let's try to figure it out first without running the code, and we can then check our answer against the program's output. Let's first get a sense of the program's overall flow. We first call main. Main calls update. The execution then returns to main, and once main exits, we return to the global scope, the scope where we define the functions main and update. Let's first look at the code in main. Here n and x are assigned in the function main, so when we get to the first print function, Python finds the objects n and x in the local scope, meaning that the values of the objects are n equal to 1 and x is equal to 0, 1, 2, 3, a list. The program then calls the function update with arguments n and x, so the program's control then moves to the function update. Although the function update has a parameter n, on the first line of the function we have an assignment n equals 2, which creates a new variable that happens to be called n, and its value is set to 2. On the second line, we append the number 4 to the object x, which is one of the function's parameters. Just to be clear on terminology, remember that an argument is an object that is passed to a function as its input when the function is called. A parameter, in contrast, is a variable that is used in the function definition to refer to that argument. That means that the second line will append the number 4 to the list that we have created in the main function. So when we get to the print function, Python finds the objects n and x in the local scope, meaning that the values of the objects are n equal to 2 and x is a list 0, 1, 2, 3, 4. Python then exits the function and control returns to the main function. Remember that variables that are created within a function, such as n in the case of the update function, are deleted as soon as Python exits that function. Looking at the final print function, the objects n and x are found in the local scope, where n is equal to 1 and x is a list 0, 1, 2, 3, 4. We can check our reasoning by running the program. If this example or some of the steps that we've just gone through are unclear to you, go through the example again, at each point using the LEGB rule to figure out how Python determines which n and x object to use.